We are going to start now the lecture 2 of chapter 6 class 10th mathematics, triangles. And in this lecture we will talk about the midpoint theorem. So the statement of the theorem is that the line segments joining the midpoint of any two sides of a triangle are parallel to the third side. So proof is simple, that we have a triangle given to us. Suppose D and E, these are the midpoints. If these are the midpoints, it means if this AD length is X, then this length is also X. If AE length is Y, then this length is also Y, because E is the midpoint of AC, D is the midpoint of AB. So what we get is that AD over DB, that is equal to X by X, that is equal to 1, Y by Y, that is equal to AE over EC. And by the converse of the basic proportionality theorem, we have these two lines, these are parallel to this DE line and this BC line, both these lines, these are parallel to each other. Next we have is proof that a line fragment drawn through the midpoint of one side of a triangle parallel to the other side bisect the third side. So we are saying again a triangle is given to us, and it is given that this D is the midpoint of AB, that is this length X and this length is X, and this line DE is parallel to the side BC. These two lines, this DE and BC, these two are parallel to each other. We have to prove that this line bisects the third line. So we are saying because these two lines, these are parallel to each other, and these lines, these are given to us, and these are this point D is the bisector. It means the ratio AD over DB, that should be equal to AE over EC, and that should be equal to 1, because this ratio we are saying both these values, these are X over X, that is equal to 1. So what we get is that AE is equal to EC. So we are saying that this E is the midpoint of AC. Next is in triangle ABC, AD is a median. This AD, this is the median. Median means we are talking about this is bisecting the side BC, and E is the midpoint of AD. This E is the midpoint of AD. If BE is produced, it meets AC at this point F. This point we are saying, show that AF is equal to 1 by 3 times AC. So to prove this, we have done the construction over here, and the construction is to draw a line DG parallel to EF. We have drawn these two lines parallel to each other. We have drawn DG parallel to EF, meeting AC at G. Now if we consider the triangle BCF, we are talking about this triangle BCF. So in this triangle we have DG is parallel to BF, and G is the midpoint of CF, because the construction that we have done, by construction part we are saying this BF is parallel to DG. D is the midpoint of BC. So this gives us that G is the midpoint of FC. We are talking about this triangle over here, and these are the two parallel lines we are talking about. Next is if we consider the triangle ADG. We are talking about this larger triangle now. This triangle we are talking about ADG. Now in this triangle we are saying again these two lines, this EF and this DG, these two lines, these are parallel to each other. Now if we look at this triangle, we are talking about this triangle now, it is ADG, and we are having this line is parallel over here, and this point E is given as the midpoint. This is given in this problem. This is given over here that E is the midpoint of AD. So we have these two lines again, these are parallel to each other. It means this point F, this is midpoint of AG. So what we get from this is, if this length GC is X, then this length FG is also X. We are saying this length FG is X, then this AG is X. It means this AF we are talking about, this is the point F. This AF, its length is X. The length of AC we are saying it is 3X. So what we get is that AF is equal to 1 by 3 times AC, and this is what we have to prove. Now the next question we have is, prove that the line segment joining the midpoints of the adjacent sides of a quadrilateral form a parallelogram. So a quadrilateral ABCD, this quadrilateral is given to us, and this PQ, R and S, these are the midpoints of the side AB, BC, CD and DA. We have to prove that this PQRS is a parallelogram. So to prove this, we have done the construction over here and we have joined A and C. We have joined these 2 points A and C. Now, if we look at this triangle ABC, we are talking about this triangle ABC. In this triangle, this P and Q, these are the midpoints. It means this AC and PQ, both these lines, these are parallel to each other. Similarly, if we look at the triangle DCA, we have this point R and this point S. These 2 points, these are the midpoints of DC and DA. So what we have is that in this triangle, these 2 are the midpoints. So it means this line SR and this line AC, these 2 are parallel. So combining the result, what we get is that these 2 lines SR and PQ, these 2 lines, these are parallel to each other. Now similarly, if we do the construction and we join these 2 points, that is D and B, then by considering the triangle DCB and the triangle DAB, by considering these 2 triangles, we can prove that these 2 lines, that is this RQ and SP, these 2 lines, these are also parallel to each other. So from this part, from the first part, we are saying that SR and PQ are parallel. Now from the second part, we are saying SP and RQ are parallel. So by combining these results, we get that PQRS is a parallelogram. Next we have is angle bisector theorem. So we have to prove that the internal bisector of an angle of a triangle divides the opposite side internally in the ratio of the sides containing the angle. So we are given a triangle ABC. This triangle we are talking about. This is ABC. This is the triangle. And the bisector of angle A is given to us. Bisector of angle means that these 2 angles, these are equal to each other. These 2 angles, these are equal to each other and meet BC in D. We are saying the bisector of this angle means from this point A we have drawn this bisector and it meets this BC at this point D. We have to prove that BD, this length BD and this length BC, we are talking about, that BD over DC, that is equal to AB over AC. So to prove this, we are going to do the construction over here and we have drawn CE parallel to DA. We have drawn a line. This is CE, we are saying this is parallel to AD, and this AB produced, it meets this at the point CE. We have drawn this angle over here and we have named this angle as 3 and this angle as angle 4. Now what we have to prove? We have to prove this result. So if we look at the angles over here, we are saying these two lines, this DA line and this line, these two lines, these are parallel to each other. So angle 2, that is equal to angle 3. These two angles, these are equal to each other because these are the alternate angles. These two angles, these are the alternate angles. And angle 1 we are saying that will be equal to angle 4. Angle 1 and angle 4, these are equal because these are the corresponding angles. These two lines, these are given to be parallel. So for these two lines, we are saying this will be a transversal. So we are saying these two angles, these are equal. Angle 1 and angle 4, they are equal because these are the corresponding angles. Now angle 1 and angle 2, they are given in the question that these two angles, these are equal because AD is angle bisector. So what we get is, by combining all these results, we get that angle 3 is equal to angle 4. Now if angle 3 and angle 4, these are equal, so this gives us AC is equal to AE. We are saying if angle 3 and angle 4, these two angles, these are equal to each other, then AC is equal to AE. Now in triangle BCE, we are talking about in the triangle BCE, this larger triangle we are talking about. Drawing this triangle over here, BCE, this larger triangle we are talking about. We have this DA. I'm again drawing this figure over here. We are talking about this triangle, this DA, and this is CE, and this point is B. We are saying these two lines, these are parallel to each other. So what we get is that BD is this length over DC is this length. We are saying it is BD over DC, that is equal to BA over AE. This is the length BA and this is the length AE. Now what we have already proved that AE is equal to AC, and this is what we have to prove, that BD over DC, that is equal to AB over AC. So in this next question, we are given in a triangle ABC, let D be a point on BC. This triangle ABC is given, and D is any point on this side BC, such that BD over DC, that is equal to AB over AC. We have to prove that AD is the bisector of angle A. This AD we are talking about, this is bisector of angle A. Bisector means we have to prove that this angle 1 and angle 2, both these angles, these are equal. So we have done the construction over here, and the construction is, we have produced this AB. We are saying we have produced this AB in such a way that we have marked this point E over here. This point E we are saying, such that AE is equal to AC, and then we have joined these two points E and C. This thing is shown over here in the figure, that we have extended this BA, the length of AE, it is equal to AC, then we have joined the point E and C. Now it is given that this length BD over DC, that is equal to AB over AC. Now AC and AE lengths, these two lengths are equal to each other by construction. So what we get is that BD over DC, that is equal to BA over AE. So this thing tells us that these two lines, this AD, we are talking about the line AD and CE, these two lines, these are parallel to each other by the converse of basic proportionality theorem. Now if these two lines, these are parallel to each other, it means this angle 3 and angle 2, these two angles, these are equal because these are alternate angles. Angle 1 and angle 4, these two angles, these are equal because these are corresponding angles. So the next thing we have is that AE is equal to AC. So what we get from this result is that angle 4 and angle 3, these two angles are also equal. We are saying angle 3 is equal to angle 4, angle 3 is equal to angle 2, angle 1 is equal to angle 4. So by combining these results, what we get is that angle 1 is equal to angle 2. These two angles, these are equal to each other. So it means AD is the bisector of angle A, and this is what we have to prove. Next, in the given figure, it is given that AD is the bisector of angle BAC. This angle we are talking about, this is angle BAC, and this AD is the angle bisector of this angle. If AB is equal to x, 10 centimeter, this AB length, this is 10 centimeter, AC length, this is 6 centimeter, BC length we are talking about, this whole length BC, this is 12 centimeter. We have to find BD and DC. Suppose we are saying this length BD is x centimeter. We have assumed that the length BD is x. So if this portion BD is x, this whole length we are saying it is 12. So we get that this DC is 12 minus x centimeters. Now from our previous theorem, what is given to us is that these two angles, that this angle and this angle, these are equal. This is the angle bisector over here. So what we have is that the ratio of these sides, these are proportional. So we have BD over DC, that is equal to AB over AC. It means x over 12 minus x, that is equal to 10 by 6. So this gives us 6x is equal to 10 into 12 minus x, that is equal to 120 minus 10x. So this gives us 16x is equal to 120. So x is equal to 7.5. So the final result we get is that BD is 7.5 and DC will be 4.5 centimeter. Next we have is, if the bisector of an angle of a triangle bisects the opposite side, prove that the triangle is isosceles. So we are given a triangle over here. This ABC is the triangle. This AD is the bisector of this angle. This angle, these two angles, these are equal to each other. And next it is given that it bisects the opposite sides. If this is length is x, then this length is also x. Now we know that if AD is the angle bisector, then BD over DC, that is equal to AB over AC. Both these lengths, these are equal. X over x, that is equal to 1. So what we get is that AB is equal to AC. From this result we are getting that AB is equal to AC, and this is what we have to prove, that the triangle is isosceles. If the diagonal BD of a quadrilateral ABCD bisects both angle B and D, prove that AB over BC. So a quadrilateral ABCD is given to us. This diagonal BD, it is bisecting angle B and it is bisecting angle D. We have to prove that AB over BC, that is equal to AD over CD. So we are going to do the construction over here, and the construction is that we have joined A and C. We have joined these two, A and C. And the point where this AC and BD meets, we are saying this point is E over here. So in triangle CBA, we are talking about this triangle CBA, BE is the bisector of angle ABC. This angle is given that these two angles, these are equal. So what we get is that AE over EC, this is equal to AB over BC. And similarly, if we are talking about this triangle ADC, we are talking about the triangle ADC. In this triangle, we have AE over EC, that is equal to AB over AD over, this is not AB, this is AD over DC. So by combining these two results, what we get is that AB over BC, that is equal to AD over CD, and this is what we have to prove. Next we are saying we are talking about the criteria for similarity of two triangles. So we are saying two triangles are similar if we have two conditions over here. First is their corresponding angles are equal. This is our first condition. And second condition we have is their corresponding sides are proportional. This is our second condition. So these can be written as, if we have two triangles, one is this triangle we are talking about A, B, C, and second triangle, say we are saying this is D, E and F. So by this definition, what we have is that angle A and angle D, these should be equal. This angle at B and angle at E should be equal, and angle at C and angle at F, these two should be equal. This is our first condition. And second condition is that AB, we are talking about this side, AB over this side, this is DE. We are talking about AB over DE, that should be equal to BC over EF. And third thing we have is that this AC and FD, we are saying these three ratios, that the ratio of their corresponding sides, they should be equal, or we are saying their corresponding sides are proportional. This is the meaning of this. They should be proportional. Now the first criteria for similarity we have, it is AAA similarity. When we were talking about the congruence, we have seen over there that if all the three angles of two triangles, we are saying that corresponding angle they are equal, then the two triangles, they need not be congruent. Over there we have studied the criteria side, that is if all the sides they are equal, then the triangles were congruent. Now we are saying if all the three angles they are equal, then the two triangles they are similar to each other. So this is explained over here, that if in two triangles the corresponding angles are equal, we are talking about this term, that the corresponding angles are equal, then their corresponding sides are proportional. We are having two conditions with us. We are saying that for the similarity of triangle, we have two conditions, that their corresponding angles are equal and their corresponding sides are proportional. Now what this condition tells us, that if the corresponding angles are equal, then the corresponding sides, they are automatically proportional for a triangle. So it means that the triangle will be similar triangles. So to prove this, we are saying we have two triangles, one is ABC and second is DEF. Now we have done some construction over here, and the construction that on this triangle DEF, by taking this point D over here, we have marked an arc P, and the length of this AB and DP, these two lengths, we are saying they are equal. Similarly from D we have marked an arc whose length is equal to AC, and we are saying this point is Q. We have joined these two points P and Q. After this we have joined these two points P and Q. Now what we have is that this length AC and this length DQ, these two lengths are also equal. Now if we talk about these two triangles, one is this triangle ABC and second we are talking about the triangle DPQ. We are talking about these two triangles. So for these two triangles, we are saying this angle at A and this angle at D, these two angles, these are equal. These two angles are equal to each other. This is given in the question. Now the sides DP and AB are equal, AC and DQ are equal. So what we get is, by SAS criteria, triangle ABC that will be congruent to triangle DPQ. So from this what we get is that this angle at B and this angle at P, these two angles these are equal. This angle at C and this angle at Q, these two angles, these will be equal. Now from the question it is already given to us that this angle at B and angle at E, these are equal to each other. This angle at C and angle at E, these two angles are equal to each other. So what we get is that angle at P and angle at E, these two angles these are equal. Similarly, angle at Q and angle at F, these two angles these are equal to each other. If these two angles are equal, we are looking at these two lines now. One is this EF and one is this PQ we are talking about. These angles these are equal to each other. So what we get is that this line PQ and EF, both these lines these are parallel to each other. Now if these two lines are parallel to each other, so what we get is that PD over DE, that is equal to DQ over DF. In place of PD we can also write it as DP over DE, that is equal to DQ over DF. Now what we have is this DP, we are saying this length DP we are talking about, this is equal to the length AB, and this DE we are talking about, DQ we are saying, this length DQ we are saying, that is equal to the length, this is equal to DE is there and this is over DF. So this is our result we are getting, that DP over DE, that is equal to AC over FD. Now similarly we can prove that AB over DE, that is equal to BC over EF. Now by combining these two results, we will get that, it is mentioned over here, that AB over DE, that is equal to BC over EF, that is equal to CA over FD. Now we have two conditions. One condition that is given in the question, that the corresponding angles are equal. This condition is given in the question. Second condition, we have proved that the ratio of their sides, they are equal, or we are saying, what this thing means, that their corresponding sides are proportional. And we know that combining these two relations or combining these two conditions, we are saying this is the definition for the similar triangles. So what we mean to say is that triangles are similar, or we are saying triangles are equiangular. This thing is mentioned over here, that triangles are similar or triangles are equiangular. It means the same thing. So it means whenever we are using the word similar, it is same as equiangular. That if all the angles of the triangle they are same, then the two triangles they are similar. Now next we have is, if we are saying the two angles of a triangle, we are talking about that we have two triangles. One is the triangle ABC and say second is the triangle DEF. We are saying angle A is equal to angle D, angle at B is equal to angle E. So we are given that two pairs, here means this A and D, D and E, these are equal. Then what we will have, suppose the value of this angle at A, it is X, angle at B it is Y. We are saying angle at D it is X, angle at E it is Y. So what is this angle C over here? It is 180 minus X plus Y. What is the angle F over here? It is 180 minus x plus y. From this what we get is that the third angle, these are automatically equal to each other. So it means the criteria that we are talking about, A similarity, it is just equivalent to the criteria AA. It means if we prove that two angles means this B is equal to E, A is equal to D, that two angles of a triangle, they are equal to two angles of another triangle, then the two triangles, they are similar to each other. This thing is, that is proving that two angles, they are equal, it is sufficient for the similarity. Next is SSS similarity. So it is given that we are given two triangles and the corresponding sides of two triangles are proportional. This is given to us. We are saying two triangles are given to us and the corresponding sides of these two triangles, these are given to be proportional. Then we have to prove that their angles are equal and hence two triangles, they are similar. So we are given two triangles, one is ABC and second DEF. These are the two triangles in which AB over DE, this is equal to BC over EF and this is equal to AC over DF. We have to prove that these two triangles, these are similar to each other. So we have done the construction and we take ABC and DEF triangles. Again the similar kind of construction as we have done in our previous question, we are doing over here, and we have cut this point DP such that this DP and AB, these two are equal, and we have cut this DQ such that DQ and AC, these two are equal to each other. Then we have joined these two points P and Q. We have joined these two points P and Q. So the condition now that is given to us is, we are saying this length AB, the condition that is given to us is that AB over DE, that is equal to BC over EF, that is equal to AC over DF. Now in place of AB we can write it as DP, in place of AC we can write it as DQ. So if we look at these two values, DP over DE, PQ over DF, these two are equal. So what we get is that these two lines we are talking about, these two lines PQ and EF, these are parallel to each other. If these two lines are parallel to each other, so it means this angle at P and this angle at E, these are equal. Next, this angle at Q and this angle at F, these two angles, these are equal. We are talking about this angle at F and this angle at Q, these two angles, these are equal to each other because these two lines, these are parallel to each other. So we get is what we are now obtaining from this. If we look at these two triangles, one is the triangle DPQ and one is the triangle DEF. We are saying this angle at P and this angle at E, these are equal. This angle at Q and this angle at F, these two angles, these are equal to each other. So combining these two results, we are saying by AA similarity, two angles are equal. It means that the triangle DPQ, that is similar to the triangle DEF. These two triangles, these are similar to each other. Now if these two triangles, these are similar to each other, so what we have is that DP over DE, we are talking about this DP, this side we are saying this is DP over DE, this whole side we are saying it is DE, that is equal to PQ, this is PQ we have, over EF. We are talking about these two, and this gives us that AB, we are talking about this side over here, these two sides, these are equal to each other. Over DE, what we get is that AB over DE. Why? Because DP and AB, these are equal to this DP, that is equal to AB, and the next we get that this, we are saying if we replace this DP with AB, we are getting that AB over DE is equal to PQ over EF. But in the question it is already given that AB over DE, that is equal to BC over EF. So by combining these two results, it is shown on the next slide, that by combining these two results we get that PQ over EF, that is equal to BC over EF, and this gives us that BC is equal to PQ. Now we are talking about two triangles over here. One is the triangle ABC, second is this triangle DEF. We have drawn the points PQ such that this AB is equal to this, DQ is equal to BC, and the third thing that we have already proved is that this PQ and BC, these are equal to each other. So what we get is that the triangle ABC is congruent to the triangle PD. When we are talking about it is A over here, then the correspondence is with D, then P and Q. This is by, we are talking about two different criteria. One is SS or SSS, criteria for similarity. Second we are talking about is SS, this is not SS, we are talking about SSS, criteria for similarity, and second we are talking about SSS, criteria for congruence. When we are talking about the congruence criteria, we are saying that all three sides of one triangle are equal to corresponding side of other triangle. But when we are talking about SSS similarity criteria, we are not talking about equal to. In place of equal to, we are talking about the proportional. These sides, these are proportional to each other. Now over here we have these three sides, these are equal to each other. So we are saying both these triangles, these are congruent. If they are congruent, they will be similar also, but it is not necessary that two similar triangles, they will be congruent. So if both these triangles, they are similar to congruent to each other, so it means angle at B and P, these angles, these are equal. This angle at Q and this angle at C, these are equal. This angle at D and this angle at A, these are equal. We have already proved that this angle at P and E, these two angles, these are equal. Angle at Q and F, these two angles, these are equal. So combining these results, what we get is that angle A and angle D, angle B and angle E, angle C and angle F, these are all angles, these are equal in pairwise. And we know that by the SS criteria of similarity, we are saying that both these angles, both these triangles, these are similar to each other. Now the next similarity criteria we have, it is SAS similarity. So in this criteria, we are saying that two triangles ABC and DEF, they will be similar if we are talking about the two triangles. One is the triangle ABC and second is the triangle DEF. When we were talking about the SAS congruence criteria, we are talking about SAS congruence criteria, we are saying that the side AB, that is equal to DE, the side AC, that is equal to DF, and angle at A is equal to angle at D. This is for the congruence. Now we are talking about the SAS similarity. So this condition of equality, it is replaced with AB over DE, that is equal to AC over DF. that is the sides they are proportional and angle between these two sides they are equal. We are saying that this side AB over DE, that is equal to AC over DF, and this angle between these two sides, these are equal. If this condition is satisfied, then we are saying that the two triangles will be similar to each other. So in place of the equal side, we are saying the sides they are proportional to each other. So the construction we are going to do over here is that, again, from this point D we have drawn this P and Q points such that this AB length and DP length they are equal, this AC length and DQ length they are equal, and we have joined these points P and Q. So in the triangle ABC and DPQ, we have these two triangles we are talking about, these are congruent to each other. This is by SAS criteria. This thing we have also seen in our previous proof, that both these triangles ABC and DPQ, both these triangles, these are congruent to each other. So what we get is that angle at A, that is equal to angle at D, angle at B, that is equal to angle at P, and this angle at C, that is equal to angle at Q. All these angles, these are equal. Next thing that is given to us is that AB over DE, this is equal to AC over DF. This thing is given to us, that their sides they are proportional. Now we have this AB is equal to DP, this AC we have, this is equal to DQ. So we obtain the relation that DP over DE, this is equal to DQ over DF. So this thing gives us that PQ and EF, these two lines, these are parallel to each other by basic proportionality theorem. If these two lines are parallel to each other, it means this angle at P and this angle at E, these are equal. This angle at Q and this angle at F, these are equal. So what we get is that angle at B is equal to angle at E, angle at C is equal to angle at F. In these two triangles, this angle at B and E, this is C and F, these angles, these are equal to each other. So by SS criteria of similarity, these two triangles, these are similar to each other. Now next we have is, if a perpendicular is drawn from the vertex of the right angle of a right angle triangle to the hypotenuse, then the triangles are on the both sides of the perpendicular are similar to the whole triangle and also to each other. Now in this next question, we are given that if a perpendicular is drawn from the vertex of a right angle triangle, so this ABC is right angled triangle, it is right angled at A, and a perpendicular is drawn from this A to this side BC. This BC is the hypotenuse over here, and this perpendicular is drawn. It means this angle at A it is 90 degree, this angle at D is 90 degrees. So we have to prove that the triangles on the both sides of the perpendicular are similar to whole triangle and to each other. So we have to prove that this triangle ABC, it is similar to the triangle ADB and similar to the triangle ADC. So if we look at these two triangles, we are saying this angle at A is 90 degree, the angle at D is 90 degree in both these cases. Then this angle at B and this angle at B, these two angles are equal. These angles are equal. These are same angles. Then we are saying that this angle at C and this angle at C, these are also equal. These are same angles we are talking about. So if we are talking about the triangle ABC, we are saying this angle at A and angle at B, these two are, this angle at A, this is equal to angle at D, angle at B, this is equal to angle at B. So by AA similarity criteria, both these triangles, these are similar. Similarly, For these two triangles, we are saying this angle at A, it is equal to angle at D. This angle at C and this angle at C, both these are equal. So we are saying that both these triangles, these are similar. So these are our first two parts, that the triangles on both sides of perpendicular are similar to the whole triangle. Now in this third part, we have to prove that the smaller triangles we are talking about, these are similar to each other. So we are now having two triangles. One is this triangle D A B, and second we are talking about D A C. In both these triangles, this angle we are saying, this angle at D, this is 90 degrees angle, and the sum of these angles at A, the sum of both these angles, their sum is 90 degrees. Suppose we are naming these angles, at this angle at B it is X, this angle as Y, Z, and this angle as W. So now what we have is that X plus Y is 90 degree, W plus Z is 90 degree, and Z plus Y is 90 degrees. Now from this equation, if we calculate the value of Z, it is 90 minus Y. We substitute this value of Z in this equation and we get it is W plus 90 minus Y is equal to 90 degree. These two gets cancelled and the answer we are left with is that W is equal to Y. So what we have is that this angle at C, this is equal to angle at A. So if we look at these two triangles, we have the angle at D, these are equal, and this angle at C and angle at A, these are equal. So by AA similarity criteria, we are saying that both these triangles, these are similar to each other, and this is what we have to prove.